Welcome to our exploration of network communications, where today we'll be tracking the journey of an image from a server to a client computer across a network. In this segment, we see the client computer request the Mona Lisa painting. Once the server receives this request, it immediately processes the packet containing the client's and its own IP addresses, along with the request details. Using TCP/IP protocols, the server deciphers this data to understand and fulfill the request. Next, we'll explore how the server prepares and sends this iconic image back to the client. Before data begin a digital journey from server to client, it must be properly packaged. This is where data encapsulation, a fundamental concept in network communications, comes into play. So it must navigate through the structured layers of the OSI model. Specifically, the data traverses 5 key layers, each playing a critical role in the seamless delivery of the image, starting from the application layer, where the image is first prepared for transmission. Then it moves to the transport layer. Here, it is segmented and prepared with TCP headers for reliable transmission. At the network layer, the data is packaged into datagrams. Here, the data is packaged into frames. This layer is responsible for node-to-node data transfer and error detection. It ensures that frames are sent and received correctly across the physical medium. Finally, the physical layer. The data is transmitted as raw bit streams over a physical medium. Let's explore the process in network layer. The data is packaged into datagrams. Here, an IP header is added, which includes important information for routing. The data portion of the datagram contains all transmission details, including the destination IP address, such as 192.168. 1.1. This is IP header format. It is added to data packets to help them reach their destination. It includes the source IP address, showing where the data comes from, and the destination IP address, indicating where it's going and others. When transmitting data from the server to router 1, it includes the source IP address and the destination IP address, which in this case is R1's address. In the data link layer, a MAC header is added to the data frames. This MAC header is added to the datagram received from the upper layer. Once the MAC header is attached, the frame is then passed to the physical layer for transmission as raw bits over the physical medium. This MAC header includes the source and destination MAC addresses, which uniquely identify devices on the local network. For server to R1, it is like this. In summary, the Mona Lisa painting, once encapsulated and processed, is converted into binary data. This allows it to be transferred efficiently through a network, following the steps outlined in the OSI model. Once the encapsulated data reaches router R1, the routing table determines that router R2 is the next hop. But what happens if the size of the IP datagram exceeds the MTU, or maximum transmission unit, of the Ethernet media? In this case, the IP datagram is too large to fit, so router R1 has to fragment it, breaking it into smaller packets that can be sent across the network efficiently. Here's a visual of how the IP datagram fragmentation process works. It gets split into 3 smaller pieces, each with its own new IP header marked here as IPHDR1, IPHDR2, and IPHDR3. Each fragment carries a portion of the original data. These smaller units pass through the network within the size limits specified by the MTU. This ensures that the entire datagram can reach its destination, where it will be reassembled back into its original form with help of the identification of the IP header. So, our data has successfully journeyed through router R1, moved on to router R2, and is now currently at router R7. As our data reaches router R7, it is now close to its final destination, the client. Before forwarding the data, R7 needs to ensure it has the correct physical address to send the packets to the client on the local network. This is where the ARP, Address Resolution Protocol, comes into play. R7 sends an ARP request to resolve the IP address of the client into its corresponding MAC address, ensuring the data packets are directed accurately to the client's physical network interface. Now, let's take a closer look at the ARP packet format. The Address Resolution Protocol, or ARP, is crucial for mapping IP addresses to MAC addresses on a local network. When R7 receives the ARP response, it confirms the destination MAC address associated with the requested IP. With this information, R7 can now forward the data to the client through R8. This process ensures that the data reaches the intended recipient accurately, leveraging the correct MAC address to facilitate smooth communication over the network. When the data arrives at the client, a process known as decapsulation takes place. Decapsulation is the reverse of encapsulation, where the headers added by each protocol layer during transmission are removed as the data moves up through the network stack. Now, let's discuss what decapsulation involves. The client system will remove the Ethernet header and physical layer. Here, the MAC, Media Access Control, header is removed. In our example, the Ethernet frame, which encapsulates the network data, also includes an LLC, Logical Link Control, header that is stripped away. The network layer, typically involving IP, Internet Protocol, discards its header, which helps route the data packet from its source to the correct destination. This layer could involve protocols like TCP or UDP. The transport layer headers are removed, which control aspects like port management and data segmentation. Finally, the data reaches the application layer, which is where it becomes usable data for the application, devoid of any headers or additional protocol information. In summary, data passes through several critical layers. By the time it reaches the application layer on the client's computer, it's no longer just bits and bytes wrapped in multiple headers. It's now the familiar, meticulously detailed image of the Mona Lisa, ready to be displayed in all its glory.